Okay, so today's our first day of simplifying and solving logs. So let's go over a couple things for simplifying and then we'll get into our solving. So if you look over here on the right, we have our reminder that E is the opposite of ln and exponents are the opposite of logs because they have this when they have the same bases. So let's start simplifying. Let's look at this first one. If we look at this first one, the problem is we've got to simplify that exponent first. So go back to your properties rules. What do we do with the numbers out in front? Well, the numbers out in front become powers. So really we have e to the ln of e to the fourth minus ln of e to the third. Now what does subtraction change to? Subtraction changes to division. So we have e to the fourth over e to the third. And then we can simplify that fraction to really have e to the ln of e. Well, e to the ln, those cancel, so we're left with e. Now, if you put e into your calculator, e to the first power, you are going to get a decimal that does not ever end, and it's approximately 2.71. Let's do the next one. So on number 2, a little bit different. Now we're taking the natural log of e, but we have that number out in front. So we're going to bring this guy over here. And what are we going to do with power to a power? Power to a power, we're going to multiply. So when we multiply those, we really have ln of e to the sixth. Well, ln of e, what happens there? It cancels, it brings that power down, and there's your answer. Okay, evaluate. Log of 10 to the fifth. Log of 10 to the fifth. Well, what are we going to do here? What do we know about logs? For logs, what's the base if nothing's written? If nothing's written as the base, we have base 10 to the 10 to the fifth. So let's think about that. Let's say it equals x. If I convert that, I have 10 to what power equals 10 to the fifth? So x equals 5. And that's evaluated. Now let's get into some solving. So here's one thing I want you to remember. Remember back when we were doing exponents, one very important piece was when it's 1 to 1, we could set them equal. Well, same thing happens when we have logs. If they have the same base, like over here on the right, if they have the same base, you can just set the other stuff equal. So look at number 4. On number 4, we have a log equal to a log. Well, they have the same base of 3, so what we can do is take this stuff inside the parentheses and set it equal. So really we have 2x equals 24, so x equals 12. Now, let's look at one with ln. Same thing. What's the base of a natural log? E. So we have e here and e here. Well, those have the same base. So what can we do? We can take the stuff inside and we can set it equal. So we have 4x plus 2 equals 3x plus 18. Solve that down and you end up with x equals 16. Now they do get a little harder than that. Let's look at this one. So this one, we don't have only one log on the left, right? We've got to get it down to only one log on the left. Well, what's it plus change to? Plus changes to multiplication. So we have log of x times x minus 3 equals log of x plus 21. And I'm going to simplify that down before I start doing anything. So let's distribute this x to get log of x squared minus 3x All right, now I have a log equal to a log. No bases are written, which means they both have a base of 10. So we can take what's inside and set them equal. So we have x squared minus 3x equals x plus 21. Well, on this one, my x squared is not going to cancel. It's still there. So we have a quadratic. Well, how do we solve quadratics? We're going to get it equal to 0, and then we're going to solve it down. So I'm going to subtract x, subtract 21. So I have x squared minus 4x minus 21 equals 0. Is it factorable? Do you want to use quadratic formula? What do you want to use? Well, this one's nice because it's factorable. So we can factor this into x minus 7 times x plus 3. So on this one, we technically have two answers. But let's talk about that. Picture your graph for a log. For our graph for the parent function of a log, it looks like this. So what numbers will we never get out as an output or a range for a log? We're never going to get a negative number. We can't even plug in a negative number for our x's. Our domains aren't negative either. So that's what we have to remember. We have to remember to check our solutions. Check for extraneous solutions. Extraneous solutions are basically no solution, or they don't work. Okay, that's when it becomes a negative. So if I come back up here to the very original problem, my two answers are 7 and negative 3. Well, if I plug in 7 to each of those, I would have log of 7, which we can do, plus log of 7 minus 3, which we can do. That's fine. And then on the other side, we would have log of 7 plus 21. Well, that also gives us all positives. So 7's good. We can use that one. Now plug in negative 3. Log of negative 3. Uh-oh, can't do that. Can't take a log of a negative. Done. So negative 3 is not a solution. So your only real solution is 7. Your extraneous solution is negative 3.